Have you ever looked up at the sky and wondered, what is the true shape of the ground beneath our feet? Is Earth really round? Or is that simply something we have believed since childhood? For thousands of years, humans have searched for the answer to this question. Some believed Earth was a giant sphere, while others imagined that we lived on a flat surface beneath a dome-like sky. But if Earth is round, one simple question immediately comes to mind. If we are standing on its surface, then why don't we simply fall off? And if Earth is flat, then why do ships disappearing into the distance often seem to vanish from the bottom upward, rather than simply becoming smaller and smaller? This is where the story stops being just a debate and becomes a scientific question. And to answer it, we need more than opinions. We need evidence. Today we have satellites, photographs taken from space, and space stations that allow humans to observe Earth directly. But how did people thousands of years ago know the shape of Earth when none of this technology existed? One fascinating answer comes from the ideas of a famous Greek philosopher who lived more than 2,000 years ago, Aristotle. Aristotle observed that during a lunar eclipse, Earth's shadow falls across the surface of the moon, and that shadow always appears curved and circular. For Aristotle, this was an important clue. If Earth's shadow consistently appeared round during lunar eclipses, one of the simplest scientific explanations was that Earth itself was spherical. But the story does not end there. People at that time had no way to see Earth from space. Yet they had another piece of evidence that could be observed with their own eye. Stand on the coast and carefully watch a ship moving toward the horizon. At first, the entire ship is visible. But as it moves farther away, its lower section begins to disappear from view first. And if you move to a higher position, you may be able to see more of that same ship again. That happens because increasing your height changes your line of sight toward the horizon. But there is an important point to understand. A ship disappearing into the distance by itself does not prove that Earth is round, because atmospheric conditions, waves, and the limits of human vision can also affect what we. That is why science does not make a conclusion based on a single observation. Instead, it brings different observations together and asks which model explains all of them most successfully. And now we come to a piece of evidence that was discovered not in the sky, but by standing right here on Earth. An experiment that allowed humans to estimate the size of our planet without using a single satellite. More than 2,000 years ago, a Greek scholar carried out an experiment that changed the way people could measure Earth. His name was Eratosthenes. Eratosthenes learned that on a particular day of the year, around midday in the city of Syene, the sun was almost directly overhead, creating almost no shadow from a vertical stick. But at that exact time, hundreds of kilometers away in Alexandria, a vertical stick produced a small but clearly visible shadow. And this is where the real question began. If the sun is extremely far away and its rays are arriving from nearly the same direction, then why were the angles of the shadows different in two different locations? Eratosthenes measured that angle, and then used geometry to estimate how long the complete circumference of Earth would be. Eratosthenes measured that angle, and then used geometry to estimate how long the complete circumference of Earth would be. But one question still remains. Was the Eratosthenes experiment truly evidence that Earth is spherical? Or could a flat Earth model somehow explain the same observation? To find out, we need to examine the evidence for both models.